So what if the massive, world-changing power that's driving the AI revolution could also fix cryptocurrency's single biggest problem? Today, we're going to dive into a really fascinating research paper that proposes exactly that, a way to stop wasting unbelievable amounts of energy on crypto mining and instead use that same effort to do something useful, like training AI models. It's a potential breakthrough that could finally bring these two worlds together. Let's get into it. To really get why this is such a game changer, you have to understand the scale of the problem we're talking about. Just Bitcoin mining by itself uses up over 2% of all the electricity consumed in the entire United States every single year. Just think about that. It's a staggering amount of energy. And that really gets to the heart of the issue with Bitcoin's security system, which is called proof of work. I mean, don't get me wrong, it's incredibly secure, but the work itself is, by design, completely useless for anything else. All that electricity, all that powerful computer hardware, it's all spent solving a random puzzle that has no other purpose at all. The process is pretty straightforward. You've got miners who collect transactions. They all race to solve this incredibly difficult but totally arbitrary math problem. The first one to solve it wins, adds the next block to the chain, and gets a nice crypto reward. But here's the kicker, step 4. After all that effort, the solution to the puzzle is just thrown away. It's like spending a ton of energy building this beautiful, complex machine, only to immediately toss it in the garbage. And this isn't some new complaint. In fact, the computer scientists who first came up with the idea of proofs of work way back in 1992 were already pointing this out. They were already dreaming of a better way, a system where all that computational heavy lifting could actually accomplish something useful. And that dream actually has a name, proof of useful work, or PoUW. For decades, this has been like the holy grail for computer scientists in this space. The core idea is to build a system where the massive amount of computation that secures the network is also producing something that has real value out in the world. So let's just be super clear about what we're talking about. A proof of useful work system isn't about solving random puzzles. Instead, the mining process is actually performing a calculation that someone out there is willing to pay for. Think things like scientific modeling, drug discovery, or, as we're about to see, training a giant AI model. Now, for a system like this to actually work in the real world, it has to nail 3 things. First, the work has to have real economic value. Obvious, right? Second, it has to be efficient. You can't add a ton of extra steps that make it slower than just doing the work normally. And third, and this is the one that's been the real monster to solve, it has to be secure. You have to make it impossible for people to cheat. And that security problem is exactly why, for so long, proof of useful work felt like pure science fiction. It's one thing to say you want the work to be useful, but it's a whole other ballgame to actually build a system that people can't exploit. So yeah, what is the catch? Why has this simple-sounding idea stumped some of the smartest people in the world for years? Well, it all boils down to one fundamental security problem. This is the core dilemma. An honest miner does the hard work that a customer is paying for, and they generate a proof that they did it. But a malicious miner, they're always looking for a shortcut. Why solve a really hard problem if you could solve a super easy one, like, say, multiplying a giant number by 0, and still create a proof that looks legit and lets you claim the reward? Stopping that kind of cheating is the whole challenge. This was considered so hard, in fact, that even huge figures in the crypto world like Vitalik Buterin, the co-founder of Ethereum, basically said it was probably not feasible. That belief is a big reason why major projects like Ethereum just gave up on the idea and moved to other systems like proof of stake. But this new research says, hang on a second. It proposes a solution. And the breakthrough is this incredibly clever trick that revolves around the single most important piece of math in all of modern AI. That's right. Matrix multiplication. It might sound boring, but it is the literal engine behind everything from ChatGPT to Midjourney. And it turns out, the very structure of this one operation might just hold the key to a secure proof of useful work. Okay, stick with me, because this is really elegant. Instead of just doing the math a customer asks for, the system first adds a bit of random but very specific noise into the problem. The miner then has to solve this new, slightly harder, noisy version. Now, here's the brilliant part. To get paid, the miner can't just hand in the final answer. They have to submit a proof of their entire work process, kind of like showing your work on a math test. And finally, because that noise was added in a very specific way, it can be easily subtracted at the end, leaving you with the clean, useful result the customer wanted. And that right there is the secret sauce, the security trick. A cheater can't just pick an easy problem because the random noise scrambles everything up. It ensures that every version of the problem is a hard version. By forcing the miner to prove they went through the entire process, you guarantee they actually did the hard work. The proof isn't the answer, it's the journey. Okay, so what does this all mean for the real world? It means we could have this incredible synergy, a genuine 2-for-1 special that could totally reshape both the AI and crypto industries. And this is why focusing on matrix multiplication is so genius. It's not just a part of AI workloads. In many models, it's the vast majority of the work. We're talking 70% or even more. So by making that specific work useful for a blockchain, you're tapping into the biggest energy consumer in the entire AI ecosystem. Let's just look at this side by side. The old way, AI computation is a huge cost for businesses, and crypto mining is just, well, a huge waste of energy. But in this new PoUW world, a company training an AI model could have its costs subsidized by earning crypto rewards. And crypto miners? Instead of burning electricity on puzzles, they'd be producing valuable AI results. It becomes a win-win. The end result is a totally new kind of blockchain. Imagine a network where the very act of a company running its AI models is the same act that secures the entire decentralized financial system. The useful work gets done, and the network is secured, all at the same time. And this leaves us with a really provocative question to think about. For years, AI and crypto have felt like two separate revolutions running on parallel tracks. But with a breakthrough like this, you have to wonder what happens when those tracks finally merge. Could the unstoppable, explosive growth of AI be the engine that powers the entire next generation of crypto? It is an absolutely fascinating thought.